Hi, I'm Jonathan Oxer, and this is SuperHouse. Now, if you are wiring up your house for home automation, the best way to do it is to have all the cables running directly from your loads, like your lights, fans, everything else, back to a central location for control. This is a star topology, and what it means is that all of your logic can be in one location, makes it really easy for upgrades, and it means that there is nothing between your electronics and your load than a bit of wire, so there's almost nothing to go wrong. Now, I was lucky enough to be able to totally rewire my house. We were doing renovation, so we ripped out all the cabling, we put in new wire, but what happens if you are renting, or if you're doing a retrofit to a house and you can't just rip out all of the cabling and do it from scratch? There needs to be a better way. I have many viewers who contact me saying, I'm renting a house and I want to be able to control things, but I can't modify the wiring. Or it might be an older house. So there are some solutions. You don't necessarily have to do a total rip and replace. You can retrofit little devices to let you control things around the house. Let's have a look at how you can do it. Now, one good way to solve this problem is to install something like a smart light globe. This is a Lifx light globe, which is LED based, it's got built-in Wi-Fi. So what happens is you just take out your old light globe, screw this one in its place, connect it up to your Wi-Fi network, and away you go. You've got control over your lights. But sometimes you can't do that. You may have a light fitting that requires an unusual bulb, or perhaps you want to control something like a fan or some other device around your house that you can't just get a direct replacement for. But you don't want to rewire it either. So the way you can do that is by putting a device in series with the power line to turn it on and off. Basically, you just cut the wire that goes to the device, splice something in the middle, something that can accept commands and turn the output on and off, and then you've got control over your device. I've done that with a couple of different things. For example, this is a blind controller that I did a little while ago. In fact, I have 4 different generations of this. I've made a few of these. What this does is sit within the tube of the blind, and you have power running in the end, and this has outputs that allows it to turn a motor on and off in either direction, so it can make the blind go up, blind go down. It's got a little particle photon board on it which has Wi-Fi built in, so I can send commands to it by Wi-Fi. There is a 433 MHz receiver, so I can send commands using a handheld transmitter as well. Now, this is another device which is quite similar. This is a light switch replacement that I worked on a little while ago. It has power in, and then it's got some relays on here and power out. Once again, there's a particle photon. It's got some buttons on the front. And the idea with this one is that you simply take off your old light switch and then put this in its place. You can control the outputs either via Wi-Fi or 433 MHz, or you can press the buttons on the front, which then sends commands and turns the lights on and off as well. That way you have the flexibility of both direct physical control. You can just walk up to the switch on the wall, press the button and turn the lights on and off, or you can control it from your home automation system, something like an OpenHAB system. So that is the way it's done a lot of the time, and you can certainly build devices like this yourself. But it takes a fair bit of knowledge, and also you've got to be really careful because you're dealing with mains level voltages. If things go wrong, you can burn down your house. You can have a really bad day. So, and also it's just work. It's hard to make one of these. So recently I got a bunch of little devices from Itead. They make these really cool little devices that sit in line. They basically do exactly what I was describing. It's a device called a Sonoff, and it's got an ESP8266 processor in it which has Wi-Fi built in, and it has input on one side, output on the other, and you can send commands to it and turn the output on and off. Really cool, very simple. So let's look at these things in more detail. So here we have the basic Sonoff. It's really quite small, really nicely made. It's in this plastic container, and it's got connections for the input and the output. So let's look at how this would fit into a typical circuit. Normally what you have is some kind of a power source which is going to have an active and a neutral line going to your load, and that could be a lamp, could be a fan, doesn't really matter. And normally what will happen is that you'll have a switch somewhere in here, so there might be a switch in the active line. What you do with the Sonoff is simply cut the wire, and you have the input, the power side coming in here, the output going out here to whatever your load is. And this just takes the place of the switch, so it then has software control over whether power reaches the load. So what's going on inside the Sonoff is something like this. Let's replace our diagram here, we'll recreate it. So we've got our lamp or our fan, and we have the neutral line. Sitting in the middle here we have our Sonoff, and it has the active coming in here and neutral, and out here we've got active and neutral going to the load. Internally the neutral line is simply connected straight through. The active line goes to a relay, and that can be turned on and off to allow power to go to the load. Also inside here is a little switch mode power supply, and that is piggybacked off the input lines. Then there is an ESP8266, and that is getting power from its little switch mode power supply and controlling the relay, which then controls the output. So what this means is that by putting this little device in line with the wire, we can communicate to it either by Wi-Fi or by 433 MHz RF. And it gives us the ability to control this without changing any other wiring. Just put this in place. So what we've seen here so far is the base model. This is a very simple little device. But it also comes in other form factors. This is a slightly different one. It's got some of the same functionality, but it also has a socket on the side where you can plug in sensors. So in this case I have a sensor here which is a temperature and humidity sensor. This can simply plug into the side, and then in a similar way we can splice this in, so we've got input and output that controls the load. On the bottom here it's got the ESP8266, and we now also have temperature and humidity sensor. So with the base model we can just control loads on and off. With this you can control loads, but it can also make decisions based on environmental conditions. So with this you could do something like control an air conditioning system or heating and cooling system, and basically this can be a thermostat, or perhaps it could be a humidity controller for a greenhouse. All sorts of possibilities with that. Now the same thing conceptually is inside this. So what this does is simply sit in between a regular screw light globe and a light fitting, and it has all of the same circuitry as in the regular Sonoff. It's just in this form factor. And what that means is you can take a standard lamp, unscrew the globe, screw this in its place, put the lamp back in, and now you've got an intelligent controllable light. Now you can make devices like this yourself, and I've done it before, but the thing is this little Sonoff is only about $7, ready to go, all like this in its plastic case, and that is an amazing deal. So for that sort of price it's not worth making your own. You just buy one of these, cut the wire, and away you go. So let's have a look at what's inside it too. I'm quite curious to see that. Well, there we have just a simple plastic shell, and here we have the main device. So it's got its input on one end and its output on the other. Now the interesting thing is that they've totally separated the high voltage section here. You can see that there are slots in the PCB, so the pass-through for the neutral just travels straight through from the input side to the output side, and then the active comes through here, and you can see very clearly it goes to the relay pins and then passes on from the other relay pin to the output. So this is very simple. You can see directly here the active and neutral are just passing straight through the module coming out the other side, broken only by the relay. On the top here you can see a little power supply circuit. That's what basically vampires off the power from the load that it's switching and runs all of the control circuitry. Under here is the ESP8266, which is the microprocessor that provides Wi-Fi and has the RF receiver as well. And on the circuit board here you can see the little strip antenna, if I get the angle just right. And in fact this part of the board is very similar to what you would see on something like an ESP8266 module, like an ESP12. It's just that it's all been built onto the same PCB for cost saving. So this is really just an ESP based microcontroller board with a built-in power supply and a relay on an output. It's a very clever little design. I like it. And they have obviously gone to a bit of trouble with isolation here, trying to protect the low-level circuitry from mains voltages and preventing arcs and flashovers there. But this brings up a really important point. This isn't CTIC approved. Now in Australia, to put anything like this permanently in, we need to have all of the approvals in place. It needs to have the proper certification, and this is not. So for hobbyist use, this is fantastic. It's the sort of thing that saves you a whole lot of trouble. But right now, you probably couldn't install this and get away with it in Australia as a permanent installation. As something that you use as a hobbyist to experiment with, fine, go for it. But you really need to check the local regulations to see if you're allowed to use devices like this. I've hooked up the Sonoff unit so that we can see how all the wires fit together. This is the power coming in from the left. I've just used a power cable that I can plug into a power point. And you can see that the active and the neutral come in on the left, and active and neutral come out on the right. And then I've wired it up to this old bayonet light fitting that I had lying around. You can also see that the earth connection comes around here. There is no pass-through earth connection on the Sonoff unit, so if you require earth, you need to connect it up yourself. So now we have everything in place to actually try this out. But of course, having the electronics and having everything wired up is only half the problem. The other half is the software. Now this is where things are really interesting as well, because Itead supply the Sonoff unit with firmware pre-installed which allows you to control it from a mobile phone, either an Android device or an iPhone or other iOS device. So you can just plug this in, pair it up, link it up to your existing Wi-Fi network and use it pretty much out of the box. You don't need to do any software development at all. You can also put your own software on it. We'll get to that in a minute. But first, let's look at the software that they supply and see how well that works. So I'm just going to start by going into the App Store or Play Store if you're on iOS, and you need to search for an app called eWeLink. That's the one, and I've already got it installed. I haven't done any setup yet, but I've got the app installed. So I'll open it. One of the first things that it does is ask you to set up an account. So this all uses an online service to manage your devices. And you can bypass all of this, as I said, by running your own software, but I'm just going to test out this included system. Right now it says you don't have any devices yet, please add. So first thing I need to do is power up the Sonoff device. Now to put the Sonoff into pairing mode, I need to press and hold this button until we get fast blinking on this LED. Now it's a bit hard to see under this lighting because we've got bright lights on here and the camera doesn't pick it up very well. But I'm just holding the button down and now it's fast blinking. So it should now be advertising its wireless network that we can connect to. On my phone I'll go into Settings, into Wi-Fi, and we'll see, look, it's found Itead and then a number. So that is the network that is being broadcast by the Sonoff. I can select that, enter password. The default password is just 1, 2, 3, 4, 5, 6, 7, 8, and join. Now we should be able to connect to it. So if I now jump back out of here and I go back into the eWeLink software, I'll go to add a device. Yes, I've done all of that. So now what it's wanting me to do is specify the Wi-Fi that the Sonoff will connect to. So I'll select name of Wi-Fi and I'll put in the name of my network, which of course is SuperHouse, and the password, but I don't want you to see this. So now it's pairing, It's telling the device that it is connecting to my home Wi-Fi network. Network is available, so it's all done. Please name this device. Let's give it some other name. We'll say test lamp. Add. Fantastic. So now we have this little device. This is the big test. Get my lamp in view here, and we'll see if we can turn it on. There we go. So we now have control over the lamp from the phone. You can hear the relay clicking that's inside here, and it was as easy as that. So we now have control from our mobile device over some mains appliance, all for about $7. So we've now got basic control. We can just turn this device on and off, really easy. There are also a couple of other functions in the software. For example, you can set a timer. So to add a timer, we just click on the little timer icon. It says there are no timers, so I'll go new timer. You can have it either repeat or just go on once. And you can also set day of the week and what the event is going to be. It's currently 5:28 and it's already selected 1 minute from now, so I'll say OK. So that's a timer that will turn it on after 1 minute. So let's see, when my time ticks over to 5:29, the lamp should turn on. And there we go, the timer executed when it went past 5:29. Now if we go back out here, we've just got direct control over the lamp again. So as you can see, this app that they provide allows you to have direct control and set schedules, so that's pretty cool. It does allow you to do some useful things. And you can also set scenes, so you could have multiple devices, group them together and say, I want to watch a movie, so turn these lights on and these lights off, or that sort of thing. But if you really want maximum flexibility and to integrate this into your home automation system, you can also install your own software directly on the Sonoff device, and that will allow us to do things like link it into OpenHAB and have direct control over it. One of the things that I really don't like is when I'm totally dependent on an external ecosystem, on some provider's cloud service, and it has to be running to be able to control devices. If my internet connection is down, I want to be able to turn the lights on and off, and I don't want everything to go down just because I can't connect to the cloud service. By installing our own firmware directly onto the Sonoff, it allows us to have direct control locally. It gives us a lot more flexibility. Let's look at how we do that. First thing you need to do is open up the box. It's fairly easily done. Just need to get a fingernail or something in the edge and crack it open. And you can pull it out and you've got the bare circuit board. Before you get into this, what you're going to do is replace the software that's running on the board, and it's not going to work anymore with the original system. So the app is going to stop working, and I'm not even sure if the binaries are available to be able to reflash it. I'm pretty sure the source code isn't available. So this is a one-way process. Once you have your own firmware running on this, you can't go back to using the eWeLink software. So think about it before you do it. But they're only a few bucks each, so if you brick it, oh well, it's not too bad. So once you've got it open, have a look in here for this header. You'll see on this particular model there are 5 little pads starting from just near this pairing button going up here. And I think on some of the earlier models there may have been 4. So it started from this end and there were just 4 going up here. This is where we need to connect a serial connection for uploading new firmware. To make things easy on myself, I'm going to solder in place a little female socket. So I'm just going to put a header in here. That means that I will be able to just use jumpers and put in the USB to serial adapter when I want to in order to upload new firmware. So I'm going to solder that on and then we'll be ready to go. So if you have it oriented like this, normal sort of orientation, and this is with input and output, we've got a 5-way connector along here. So we've got 1, 2, 3, 4, 5 sockets. The top one we're not going to use for now. Going from here, the first one is VCC, and that's 3.3 volts. So you need to make sure that you connect only at 3.3 volts, not 5 volts. Then we have RX, TX, and ground. So TX is data going out, RX is data coming in. That can be confusing because you need to think of it from the point of view of the device. People often get TX and RX mixed up. What I'm going to use to connect this to my computer is this free Tronics USB to serial converter. This effectively does the same thing as an FTDI connector, so it's got the same pin out on here as you would have on an FTDI cable. The nice thing about this is that it's got switchable 5 volt and 3.3 volts output, and it's got a 16U2 microcontroller on it, which is the same as used on the Arduino. So this just appears like an Arduino board to things like the Arduino IDE. So what I'm going to do is use some jumper cables here, just plug them in. So VCC, I'm going to use my orange cable for that. VCC there goes to the Vout pin, then ground, which is second from the top, goes to ground on the USB to serial connector. Then I'm going to have just below ground the TX pin, I'll use green for that, and TX from the Sonoff goes to the RX pin on the adapter. And then the RX pin on the Sonoff goes to the TX pin on the adapter. So now we can plug this into our computer. Treat it just like an Arduino board with the USB interface on it and flash new firmware right out of the Arduino IDE. But first I need to make an incredibly important point. Look at this. You see these connections? Notice something that is not connected. That is the mains. Do not ever connect up to one of these devices to reprogram it while you still have the mains attached. Now I know it can be really tempting because once you've installed the module and you've got the cables all screwed in place, it can be a bit of a pain. You've got to unscrew it, disconnect the mains, and you might think, oh, I'll just quickly pop in the USB adapter and the serial connection and I'll reflash the firmware without taking it out. Don't do it. I need all of my subscribers and I don't want you to zap yourself. Make sure it's disconnected before you do any updates. Now later you can, once you've got some sketch on here, do over-the-air updates as long as you have the framework set up for that. But do not connect USB while you have mains connected. Don't forget that. Remember it. It's important. Now that we have the cable in place, we need to put the Sonoff into programming mode so that it will accept something uploaded from the computer. Now the way you do that with an ESP8266 is by pulling the GPIO 0-pin low during power up. And luckily this mode button, which is provided on the Sonoff, connects to GPIO 0 and it pulls it low when you press it down. That is really super handy because what it means is that we can just press the button, power it up, let go of the button, and we're in programming mode. So the way you would do that is disconnect the power connection or hold down the button and then plug this back into the header, and it's now in programming mode and we can upload from here. Now because I do a lot of these, I found that it's annoying having to deal with these individual jumpers. You can get confused about which one goes where. I've got to look up the documentation all the time, and it's also annoying having to pull out the power connection. So I've made myself a super duper little programming cable. This cable is set up so that I can just plug it straight into the header on the Sonoff, and it's got one of the connections with a red heat shrink on it, which is pin 1, which is also VCC. And at the other end, so I can just get rid of all of these loose headers, this plugs straight into the FTDI pin out, and it has a switch on it for power. That means that I can just plug in, push the button down, turn power off, turn it back on, let go, and now we're in programming mode. Very easy. So now we have our Sonoff connected up by a USB to serial adapter. And I'm going to load Blink onto it just to show you how simple this is to get something basic running and that you can really treat this like an Arduino. The first thing we need to do is add ESP8266 support in the IDE. So start by going into Preferences, and you'll see there is an additional board manager URLs entry. You need to put an entry into there for the ESP8266. I will put the link for that in the notes for this particular video. Now if we go down to Board and into Boards Manager, it will do an update because we've just added a new source to obtain boards. I'll do a search for ESP, and you need to find ESP8266 by ESP8266 Community. I'll select that and say Install. it will then download and install the software necessary to support the ESP8266. Once that's done, we just close the boards manager, and now if we go into tools and into boards, you'll see that there are a whole lot more options. All of the ESP8266 modules listed here. For the Sonoff, we need to pick the generic ESP8266 module. Then there are a whole lot of extra options that appear. Leave flash mode DIO, flash frequency 40 MHz, CPU 80 MHz. For the flash size, we change that to 1 meg with 64K spiffs. And the rest of this you can leave pretty much as it is. You need to make sure that you pick the COM port for your USB to serial adapter. I have one there. And now we can upload Blink. So just to check that it compiles, click on compile. This will now be compiling it for the ESP8266 processor. And you can see we have success. Now all I need to do is use that process to put the Sonoff into programming mode. So I will turn off power, press the button and hold it in, turn power back on, let go, and now this is in programming mode. So I'll hold this up here so you can see it. I'll click on the upload button and it compiles the sketch again, and then it does the upload. You'll see some activity on the USB to serial adapter, and you can see progress now down the bottom. Now one thing that's very handy is that this little tricolor LED, the green element of it is connected to digital pin 13. So we don't even have to change the Blink sketch. It works straight out of the box. Once that finishes uploading, the Sonoff should reboot into Blink and we'll see the LED flashing. And there we go. It's a little bit hard to see because the LED is not very bright, but that is now blinking. So we now have a Sonoff running an Arduino sketch that we've just uploaded out of the IDE. Now that you've got to that point, you can load whatever you like on there. You can upload a sketch, something that will listen to MQTT or provide you an interface that you can connect to. So you now have full control over your Sonoff and you can treat it like an Arduino. So now that we have Blink installed on our Sonoff, let's go one step further and we'll install a version of Blink with the over-the-air update framework. That way we can put it back in its case, upload new software onto it, and we don't need to have that connection in with the USB serial adapter anymore. It makes it much safer to work with. So here we have the basic Blink. And over here I have a new version of that sketch, which is over-the-air Blink. And what I've done here is included some libraries that allow Arduino over-the-air updates. It doesn't matter if you can't read all the detail here. I'm going to provide all of this source code. Basically all it does is define an LED pin. It defines an SSID and a password for Wi-Fi, connects to Wi-Fi, and it enables some functionality that allows us to do over-the-air updates. So what I'm going to do is put my network username and password in here, but I don't want you to see that, so I'll do that and then I'll be back in a second. Now I've got this configured. At the moment we don't have any over-the-air update framework installed on this, so what I need to do is put it into programming mode. I'll turn it off, hold down the button, power back on, and now we can upload this sketch to it using the normal serial upload. So I've got COM port 4 selected. You can also see here I've got network ports. There is one network port already in existence, that's a WeMOS D1 Mini that's somewhere else on my network. So now I will upload this, and now the upload is complete and we have Blink running. Now in this particular case Blink is running faster because I set it to a 200 millisecond delay instead of a 1000 millisecond delay, but we now have Blink running on this with the over-the-air update installed. So we can now push other sketches to this once we've disconnected from the USB connection. If we look inside Tools here and at the COM port, yes, we can see now that we have a new ESP8266. It's this one right here, so we can select that, and now uploads will actually go via Wi-Fi instead of via the serial connection. So over-the-air Blink is okay, but let's look at something that's a little bit more useful. I have another sketch over here, which is over-the-air relay. So what this does is define two outputs, the relay pin, which is pin 12 for the Sonoff, and the LED pin, which is pin 13. It then subscribes to a topic called test Sonoff, and it looks for a message. If it sees a message of 0, it turns the LED and the relay off. If it sees a message of 1, it turns the LED and the relay on. So it's very simple. So now I have this over-the-air update relay output with MQTT subscription installed. And all I have to do to change the status of the output, both the LED and the relay, is to send the appropriate message to the MQTT topic. Right now this is just using USB for power. There is no data connection of any type across here. And over here I have a shell onto my MQTT broker, so I can send a command of 1 to the appropriate topic. The output turns on, the LED is on, the relay is turned on. If I send a value of 0, the LED turns off and the relay will turn off. There we go, it's as easy as that. So now we have MQTT control of a Sonoff with over-the-air software updates. I put power back on again, but now we are running the updated software. So this is running the firmware that subscribes to MQTT. Now in OpenHAB, in the Office Garage area, I have defined an item called Sonoff test, which is just bound to MQTT. So when I turn that light on, it sends a message to the MQTT broker. When I turn it off, it sends a different message. So now all I do is hit that, the lamp turns on, turn it off, lamp turns off. That was actually going over 4G, so this is quite responsive. This is connected out via the mobile network, coming into my OpenHAB server, which is then publishing to MQTT and controlling the Sonoff. So if you want to experiment with controlling mains devices using your home automation system, I highly recommend checking out the Sonoff. It's really cool. And when I said earlier that these are about $7 or so, that's actually $7 Australian. They're like $4.85 US. These things are insanely cheap. And everything I've shown you also applies to the Slamfer. Same thing, just different form factor. Open it up and you've got the same header that you can use to reflash it, and you can treat this in the same way. There is also another model which I showed you earlier, which has an input on the side. There is a 16 amp version of this. The new version also comes in a plastic case. I received this one as a bare circuit board just because I was too quick. The new ones have a nice molded case that keeps everything isolated as well. Once again, you can do the same thing with this. The only limitation to keep in mind is that these come with a 1 megabit flash on them, which is very small as far as ESP8266s go. It means that you can't really fit very much in there, particularly if you want to do over-the-air updates, because during the OTA process it needs to have a complete copy of the old image that is running and the new image before it is executed, which effectively means you have to fit your entire program into half the memory that's on the system. And when it says 1 megabit, that's 1 megabit, that's not 1 megabyte, so divide by 8 to get the actual size of the memory. It's not very much. So Pete Scargill has done some really interesting work with these, and he's discovered that you can replace the flash chip as well. I've ordered a few of the flash chips so that I can increase it from 1 megabit to 4 megabits, and that allows storage of much bigger programs. He's also done some really interesting work with his own home control software, so I highly recommend you check that out. Now I will link below in the post about this video to a whole lot of resources, and I'll provide you some source code, places to go, definitely to check out Pete Scargill's blog, and there are various other resources that'll be really handy if you want to get into this stuff. So go and build something awesome.